For this experiment, the purpose is to the determination of shear at x-axis due to loads and load position and positive and negative shear force. First, we need to set up point A, point B, which has pin support, point D, which is the cut section point, and point C that have roller support. Then we need to put the load of 100 gram in between the point D and C, and we take the value, we measure the distance from point A to the load, and we record the digital force display meter. Then we use the same load. We move to the point between B and D, and we measure the distance from point A to the load and record the digital force display meter. After that, we move the position to the point between A and B, and we do the same step, which is measured from point A to the load and record the shear value at digital force display meter. And after that, we repeat the same step from the beginning with different value of mass, which is for 200 gram and 300 gram. Then, from the data collected, we draw a shear force diagram, and from that we can determine the positive and negative value of shear force from the graph. For the shear force that below x-axis, it considered as negative shear force, and upper of the x-axis, it is considered as positive shear force. Next, we plot the graph of shear force against loads at variation position and shear force against loads of different magnitude.
Hi, my name is Muhammad Razikri bin Muhammad Ruslan. Okay, today I would like to show you the stimulation experiment of shear force at section XX due to uniform distributed load. First step, set up the equipment same as the video. This ruler represents the beam. 3 balls over here represent the load. 2 close pack represent the support for the beam. So, this is the point B and this is point C. This line over here represent the section XX that we want to find the shear force. Second step, 3 series of point load is placed 40 mm apart to one another at the left of the support B. Then find the shear force that digital display will show you at the section XX. Done for this experiment.
Assalamualaikum and hi. My name is Muhammad Saufi. So today I want to do experiment about bending moment variation at cut due to relation of load and position of load. So in this experiment we use three different mass such as 100 gram, 200 gram, and 300 gram. For the first step, we put different load between point A and B. So for the case 2, different load is placed between point B and D. And for case 3, we put different load between point B and C. After that, measure the value of bending moment or at section X for all three cases. Then, plot graph relationship between bending moment at X against location of applied load from point A. Plot another graph relationship between bending moment at X against value of applied load. Finally, plot shear force diagram and bending moment diagram to show our maximum sagging moment and maximum hogging moment have equal absolute values.
The objective of this experiment is to find the point of contraflexure where the bending moment is 0 first. To start the experiment, we must set up the equipment like this and mark the point. This is point A, this is point B, this is point C, and this is point D. Okay, next we put the load W at point A. Then we put the load P between point C and point D. Next, we measure the distance between point C and point load P, and then we get the P value by using this formula. Based on that, we can measure the bending moment at section DXX, and then we can compare the value between theoretical and experimental.
Let's continue with the last part of this experiment, which is to prove the superposition principle for bending moment. After we obtain the measurement for bending moment, we need to calculate by using few steps and equation. Firstly, we need to obtain the direction at point B by using the equation summation of bending moment at point C equals to 0. After that, we need to make a cutting at section XX so that we can obtain the bending moment by using the equation of summation of bending moment at point D equals to 0. But we need to remember, according to the superposition principle, the total bending moment at figure 4 is equal to the bending moment at figure 4A plus bending moment at figure 4B plus bending moment at figure 4C. Lastly, after we obtain the measurement and calculation at section XX, we are going to compare the values to see whether they obey the superposition principle or not.